Hello and welcome again to Rustacean Station. I'm your host, Alan Wyma, and today I'm with another very familiar guest on the show, Ben Striegel, who is also another host on Rustacean Station. You've probably heard him all the time with John. He is a computer programmer and self-proclaimed second oldest person, or second longest person, in Rust.
This is the second most senior extant Rust project person, I guess. Yeah. It's hard to say. We can get into it more later.
I'm sorry if the way I introduced you kind of came off a little bit negative, but that's not way
That's
at all.
All right. No, I'm happy to be here. So it's weird to be on the other side of an interview for a change.
Well, it's kind of less stressful, right? You don't have to do much preparation and things like that.
Yeah, a little bit. There's a different kind of stress, but
yeah. But yeah, I mean, I talked with John recently. His podcast just got released. And I asked, what would be a good way to get you on? Because, of course, your name's come quite a few times. And he mentioned that, you've been around the community for a long time. And so the history of Rust would be a great topic for you.
Oh, yeah. I can go on for days and days about Rust history. So strap in, because any question you ask, I can pontificate at length about. So feel free to just pepper me with questions and we will fill out one or more podcasts.
Well, I mean, the more we have, the better, right? Let's keep the pipeline full is what I want to hear, because I think people are just thirsty for more information about Rust and podcasts. I mean, you're still like going to the gym and doing nothing or running or something. You want to listen to something, right? And I think hallway banter is great to listen to. At least I think so. So maybe we can just talk about, what got you first interested into it? Because this is pre 1.0 you started, right?
Yeah. So actually, it occurs to me, it's approaching my 10-year anniversary, sort of like being involved with Rust. I'm pretty sure I first came to Rust in September or early October of 2011. So I should write a blog post, which first requires me to make a blog, which I've been meaning to do for almost all of that 10 years. I'll get around to it one of these days. But yeah, it was a much different place back then, much different language, different kind of like community, very nascent at the time. So yeah, I mean, I'm happy to just I figure my unique expertise is just talking about the prehistory of Rust, and there's been so much growth in the community over the past few years. I'm sure there's plenty of folks who have just no idea what it was like in the early days, or would love to learn more about what the beginning stage of what would one day become a pretty large open source project, what it looks like, how it's changed over time, that kind of stuff.
You mean really really detailed history, right?
Yeah, but also to answer your question of how I got involved, it's really, I'm not entirely sure how I first found the Rust project. I remember where I got involved. I remember I found the Rust IRC channel, which back then was on the now defunct Mozilla IRC server. And back then there were maybe 30 to 50 people in the channel, period, most of them lurking. And there was... there would have been maybe about 5 or so full-time-ish developers, all of them either working full-time or consulting for Mozilla's R&D arm. And it was a really formative time in my life. I had just gotten my first full-time programming job out of college. And it was such a different environment from college, where I had been so used to kind of coming in every day and learning something new. And when you're working in an enterprise environment, just using normal enterprise stuff, having never heard of any of the or never really delved into any of the more exotic programming languages. I was just eager to find any avenue to learn. And the old Rust IRC channel, it taught me more in a year of lurking there than in my entire CS degree. And I had a good CS degree. It was pretty good, but they were just so much real knowledge and expertise. And trying to keep up with these people who really knew what they were doing and had a real vision for what they wanted to do. It was just a fantastic time to learn. That's what kept me around. But as far as how I found it, I have no clue. I probably saw a comment in some online forum somewhere of someone saying, hey, there's this Mozilla's doing this new language project. And at the time, at my first job, I had nothing to do for the first month because they really had no idea what to do with me. They were just we have, oh man, I don't talk about myself too much, but it's just in terms of languages that are weird. Have you ever heard of a language called RPG?
No.
It's an old IBM language. You probably wouldn't have heard of it. They say that Fortran is the oldest general purpose programming language. And I'm pretty sure RPG is older than Fortran, but only because it wasn't intended as a general purpose language. It's so old that like they had all kinds of bespoke notions of like how a program should run, like what a programming loop should look like. It kind of resembles more like a kind of a declarative SQL kind of thing, but in like a really imperative Fortran style trappings. It's just like you don't want to hear, if you're into Rust, you don't want to hear about RPG, but you should look up the Hello World for like old style RPG sometime. It's quite a trip. And this place where I was working at, they were like, well, we can't really hire anybody for doing RPG anymore. They haven't taught this in colleges since the 90s. So we want to modernize, kind of like, they move their hands and a rainbow appears, sparkles fly out of their fingertips. And it's like, we want to modernize. We want to do web things. And the entire interview was, do you know what HTML is? And I was like, yeah, I'm pretty good with HTML. And they were like, you're hired. But for the first month, they didn't really know what to use for the back end. And so they were just like, look into languages. Like, I'm not really sure. Like, we don't know what to use. You're the new guy. Figure out what we're going to use this entire, huge effort. And so I was just like researching languages for that first month. And I, obviously didn't pick Rust ultimately because it was 2011 and it was extremely raw, but I managed to find out about it in my whole, language delving and just got stuck in and never left. So that's kind of how I found it and how I got here.
So all throughout this time, you picked another language and you're still kind of lurking in there and just like feeding on all the knowledge you can.
Mm-hmm. Yeah. So back then it was, there was just the IRC channel. There was a mailing list, which you can still find the archives of these days. The IRC logs are all long since gone, sadly. And then the GitHub issue tracker, and that was just pretty much it. And so I think my first interaction with the Rust community was in October of 2011. That's at least publicly archived. So yeah, I was just like talking about some back then. It was all like so open. Like you think about today we have the RFC process for Rust for proposing changes. Back then it was just like somebody has an idea, you think about it, talk about it, and then someone does it. And you can afford to do that when you're a very fast moving young language. And people these days, I think, who have been only gotten into Rust in the past or so 5 or 6 years, don't really appreciate what a reputation for instability Rust had in the early days. It changed every week. And so even though I was kind of I didn't really consider myself good with languages or programming in general, but what I really was good at is kind of just lurking every day, reading the scroll back of all the IRC and mailing list threads every single day. And anytime anything changed, anyone who was trying to use the language, they'd be like, why isn't my code working anymore? And I'd be able to point them into here's what's changed. I kind of became like a unofficial sort of secretary where it's here's what's changed, here's why this isn't working. Or if I couldn't figure it out, I'd say, here's who to ask about this whole thing, who's working on this area of the language. So yeah, it was a wild time. Anyone could just talk about anything. You could bike shed for days about the simplest topics. You could just we have there's a great issue that I filed at some point in maybe 2017 or so, where it's just here's all the features that we have deprecated and want to remove from the compiler that we just haven't gotten around to yet. And it's a huge long list of things that these days anyone who wasn't there has you'd see it and you'd be like, what does this even mean? Argument modes or implicit implicit self. And it's just none of these things, none of these experiments panned out, but it was just a wild time back then. People people might think these days of getting into Rust, it's a big language, it's complicated. I think if you weren't there in the early days, there's so much that we removed from the language. I say we, I was involved, but I wasn't a big compiler hacker back then. But so much that was removed from the language in those early days. It's just it's mind-boggling how much smaller the language actually got over time. So, oof. Like I said, I could just talk for days about Rust. So if you want to try to focus me, direct my my torrent of words, feel free.
Okay. I think. I'm just trying to think because it sounds like it was really Wild West when you kind of got in there and things just kept changing, right? When do you think you kind of had something, right? So what I do know is that Rust at some point was similar to Go in the fact that you had green threads, I think, and you had a garbage collected language. Well, it's obviously that's nothing what we have right now. So what would we say? We had something that was kind of somewhat stable, and then what was that like?
I can kind of pinpoint. So just to elaborate on. Yeah, so you hear occasionally some graybeard will say, yes, Rust used to be like Go. Really, it's so Graydon had the idea. So Graydon Hoare, the original kind of inventor of Rust, He's a huge language nerd, always into these like really academic, obscure languages, extremely knowledgeable, very smart. And so he was inspired by Rob Pike's earlier languages. So Go is not Rob Pike's first language. There was like Limbo, I think the other one was Aleph or something. All these kind of like experimental Plan 9 things, and many of them resemble Go. So they were kind of like Go's prototypes. They were to Go, these languages were to Go as like early Rust was to Rust, where it was just kind of like he's working out ideas, he's kind of experimenting with like what works and what doesn't. And so like Go did not kind of just like emerge fully formed. It was like in the works for many, many years before Google ever announced Go or anything. And so Graydon had known these languages and wanted to like, elaborate upon these ideas of like easy concurrency, memory safety in a systems context. And at the time, that was kind of like the only real like proven known way of doing memory safety was, using a garbage collector. There was a few experimental ideas in the academic literature of how to do memory safe sort of without a GC. But and even though Graydon knew about them, he kind of had a dim view. At least it seemed like he didn't seem that he had any like, confidence that it could be done, or like maybe he didn't just want to be the one to do that experimentation. So yeah, early on, I would say Rust and Go kind of had a convergent evolution because obviously Go also inspired by Rob Peck's earlier languages. And so after Go was sort of announced in 2009 and stabilized in about 2011-ish, I think that it was obvious like what was working, what wasn't working. And there were still at that point differences between early Rust and Go. But the fact that Go existed kind of pushed Rust out of that niche. But it wasn't really intentional. So to get back to your earlier question, when did Rust start to like gain its new character? I would say when Nico Matsakis kind of started working on the modern idea of like what would a borrow checker look like in terms of like what would it mean to have this sort of static analysis that would let us check that memory was being used and reclaimed properly without the need for a garbage collector. And that sort of happened slowly over time. I think that I don't have the timeline in front of me. I think it was maybe like late 2016 into 2017 when the ideas started to coalesce about, well, we have kind of we already had move semantics. And so one of the things that Graydon, even though he didn't want to get away fully from GC, he still had this idea of sort of like isolated heaps at the time. So kind of you have like to enforce memory safety in a concurrent context, you have like memory regions that like different parts of the green thread runtime can't actually access, and then you would move memory between them. And so that was kind of the early iteration of like move semantics. They weren't the default back then, but it went back and forth so much it's hard to say like what you have to say at what point what point in time. Because I think it wasn't the default, then it was the default, then it wasn't again, then it was again. Sometimes there was like explicit syntax where you have to actually use an arrow to move a thing. Sometimes there was a keyword to move a thing, and then so there's just like again so much experimentation, so much just like weird Wild West stuff going on. But move semantics were there, and then it was kind of Nico Matsakis' idea of working on the literature from a language called Cyclone, of pairing that with the move semantics that Rust had, and then over the course of like maybe a year or two, it sort of like became apparent, just like fortuitously, how good of a match these two were for each other. Because these days you think of like the borrow checker, people kind of like lump in move semantics with that, but like these were two ideas that were pretty much separate before Rust, and then Rust, like the big innovation of Rust was kind of putting these two ideas together and figuring out the best way to make them work harmoniously. So the idea, one of the ideas of Rust is, not to do too much original research. Like, there's many origins of Rust's name. One of the kind of origins is, not using any new ideas, only using old rusty ideas, but doing them the right way in, putting them together in novel ways. And this is kind of the main thing of Rust is move semantics plus regions / borrow checker. So I would say the borrow checker times were the time when Rust kind of like coalesced as its own language, because at that point it kind of became obvious that you could get away with not having a garbage collector in the language. And then moving away from the green thread runtime by default took much longer. That only happened sort of shortly before 1.0 in like 2014 or so, I recall. there were several rewrites of the green thread runtime over time to be kind of like, there was so much overhead to it, especially with interfacing with C code, and just like it eventually became apparent that you just couldn't do it with the performance targets that Rust had in mind, especially with the seamless C interrupt that they wanted. So that's kind of like, it really, but there was no like one time. It was a long continuous process towards Rust 1.0, and it kind of became obvious what the language could be. And there were so many other parts of the language that like, this had that effect on. So like if you don't have a GC, you also need to define closures appropriately, and you also want to define for loops appropriately, and you also need like, all the machinery for that. You want to have the right traits. You need to have features that allow you to abstract over these closures. So that involves various esoteric concepts like higher ranked lifetimes that are kind of a very advanced Rust topic. But it all came together. It all works very well, much to possibly the surprise of a lot of Rust developers. But yeah, I think I back then I really did not expect Rust to get as big as it did. I mean, we all kind of like knew it's almost impossible for a new language to break through. And the fact that it's gotten as big as it has, there's a lot of factors that contribute to that success, but it's still kind of a very pleasant surprise that we're still these days developing it, talking about it, and still growing. So it's so cool.
I kind of want to go back, like you mentioned move semantics. Like the only thing about move I can think of is that move keyword. Like is that related where you're moving things around? Like what do you mean by move exactly?
So as far as move semantics, I mean kind of a single ownership of values where like by default you have, anytime you make a new type, you can't say let x equals foo if foo is my new type, and then you can't say let y equals x, and then you can't use x anymore, right? So you can either opt into copy semantics if you do a derive copy on your new type, but by default, only a single owner at a time can own a thing. That's still the truth, even with copy semantics, because even with you have single ownership, you copy a thing, now you have two things, each of which are individually owned. But if you have copy semantics, it's not a kind of like, it's not that big of a deal to have single ownership. Still, it's this idea of, I don't want to use like the term linear types. It's kind of like there's linear types, there's affine types. These are all kind of academic concepts and getting into the weeds of what each one means. But single ownership is kind of the best way to summarize what the central idea is and what how Rust tries to convey it and enforce it.
All right, so because to me, I think about this as part of the borrow checker, right? So where does the move semantics kind of end, and then when does borrow checker begin, or this kind of what's the relationship between the two?
Mm-hmm. So as far as move semantics go, they're really a separate concept from the borrow checker. So imagine you have a program that doesn't use any references at all. So you never take a reference to anything. You never call any methods that take references. You can do it. You can write this program. And actually, it's a great illustration for why you want a borrow checker and the problems that references solve. So imagine you have a Rust with no borrow checker, no references entirely, but you still have move semantics. And so imagine that you want to have a function, even a method or whatever, that takes its value and then just mutates it, right? And so imagine that you have this. And so how would you write this signature in this subset of Rust without references? Well, what you could do is you could have the method take self by value and then just return self, right? So that's kind of the same thing, because you can always mutate something that you own. So you would just in every single method or function, you would pass everything by value, and then anything you wanted to return, you would pass back in the scope. This kind of gets a little bit onerous over time. If you were to actually write APIs this way, of constantly you couldn't do any kind of chaining very nicely without kind of if you wanted to pass back tuples of things. If you have if you're passing back multiple things, you have to do a lot more assignments, a lot more naming of things. And so the idea is references, especially immutable references, allow you to avoid having to pass a thing in, pass a thing back over and over and over again. And it's also just often a less overhead to pass a reference, which is always just one word in memory wide, as opposed to passing a thing by value, which could be very large. So there are both API quality of life, qualities to references, but also performance qualities. And so, but you can, in fact, have that language. And that's kind of the academic languages that, predate Rust. Just that didn't have any kind of borrow checker or pointers, just had these move semantics where you would just do that. And that's how it would work. So the fact that references solve so many problems, and that you can use this bar checker to solve those problems in a way that's still memory safe is a really happy coincidence.
Okay, that now I understand a lot more about that. That's good to know. Um, Rust, the compiler was actually written in OCaml before, right? And then they switched to
Yeah.
LLVM. Like, do you remember this? Like,
I remember the aftermath. So, yeah, so it's true. So, like, Graydon's first had the idea for Rust in like 2005, and obviously you can't write a program in a language that doesn't exist. So you have to bootstrap it from something, right? And so he chose OCaml, which you can see the influence of sort of this like ML-ish descendants, this lineage in Rust today in terms of like syntax and that kind of thing. But yeah, and so the first big program to be written in Rust was the compiler itself, the Rust-C. And the idea is that there was for like, the first 6 or so years, there was just the Rust boot, which was the OCaml compiler. And it just needed to get mature enough to support all the features being used in Rust-C so that it could compile a version of Rust-C which could compile itself. And that happened in mid-2011, which was just before I came. And I think approximately when Nico Matsakis came, who's Nico is the first most senior extant, first oldest remaining person still involved with the project. And you said before, I'm like, I'm the second oldest still remaining. There are obviously people who predate me, but they're not around anymore to my knowledge, or they're around, they're still, they're working quietly and doing their own thing. So, yeah. So bootstrapping compilers is an interesting topic. And it's kind of it's an interesting set of trade-offs. So obviously Rust-C written in Rust. And so every version of Rust is really written in the prior version of Rust. And if you wanted to, people have asked before, can I can I take the old original OCaml compiler and then the old Rust source code and like bootstrap my way back to the modern day? And it's like, you can certainly try, but like there are so many Git submodules you have to get, because like remember back then we had green threads and we had libuv as external dependency, and we didn't always do the best at pinning to the right versions, documentation, all kinds of various things. And there were again, things changed every week. You have to compile thousands of versions of the compiler with no guarantee that it would actually work at any given moment, or that there would be enough information to actually compile any given old thing. So, I mean, in theory, it's feasible, because obviously we did it. We're here today. The fact that we have this Rust-C, which has its lineage, these binaries have their lineage in the old Rust boot, thousands and thousands of generations ago. But yeah, it's quite the journey we've been through. It's actually, it might be, in respect, it would have been a lot easier for development to not bootstrap, but the benefits of bootstrapping are so immense, where it's if you had people who want to learn your language, you don't want to make them learn a separate language just to work on your language. That's the biggest one, really, is community. But other than that, it would be nice sometimes to have a compiler that is not written in Rust, just to make it faster to iterate on.
Yeah, I'm just kind of curious, why even switch away from OCaml? Was it just because it's okay, we should just stick with our own kind of tool and just, that's part of it?
Well,
it seems to be every language, it's once you can compile your own compiler, then it's okay, now we're a real language. That's kind of the feeling I have. I can only relate back to, I think CoffeeScript could compile itself, right? It seems once you could compile yourself, then you're in a good situation.
Yeah. There's a nice philosophical milestone where it's okay, we have our language is now mature enough to write a compiler, which is a non-trivial piece of software in itself. There are a lot of pragmatic benefits to not doing a bootstrapping compiler. But in terms of if you're doing an open source kind of volunteer thing, again, if you want people learning the language to be able to actually use the language, also it's just beneficial for people who are designing the language to really test out in an actual code base, does this feature we're adding actually make a benefit? How does it work? And there are dangers there where it's if you take this too far, then essentially you will just make a language that is only good for writing compilers. You need to have, ideally multiple large code bases. And fortunately, as part of Mozilla research, back then it was also Servos. There was a team writing, this new browser engine kind of experimentally in Rust. And so they also gave a lot of feedback to help improve the language, which helped a lot, in terms of not making it so that Rust was only good for writing compilers. It was just good for when you're writing this very large software using kind of onboarding a lot of former C++ developers. How is this familiar enough? Is this performant enough? That sort of thing. Yeah. So, but I mean, a lot of it too is just pride, where it's we want to, people always ask, well, if your language is so good, why isn't the compiler written in this other language? Right. So there are maybe sometimes, a lot of reasons to not write it in your own language, but at the end of the day, you still want your reference compiler to be written in the language itself if you can help it.
Yeah, that makes sense. The other thing I have a question too is like, um, I do see that Rust is looking at doing something with looking at integrating with GCC. Like, is there a reason why they chose LLVM over GCC for the compilation?
Yeah. Back in the day, so like GCC historically didn't make it extremely easy to write new backend or write new front ends, I should say, for it. So there were just a lot of like philosophical, technical, legal hurdles, kind of like all intertwined, of like making it a little bit more difficult in terms of like I'd say a little bit, but it's actually probably a lot more difficult these days. I think it's gotten better. LLVM has kind of pushed them to make the interface between front end and back end more well defined, easier to use. But just back in the day, LLVM was designed, like one of the ideas was to make it easier to write a front end in terms of having like this nice bytecode language that was relatively stable. It's not stable, but it's still like relatively stable. And it was just the right thing at the time, because back then, like even these days, like GCC probably still has a slight performance edge over LLVM. They've pretty much closed the gap. But also like LLVM has also kind of closed the gap in, like in both directions, where it's like back in the day, LLVM was both a lot faster and a lot better at error messages than like, GCC based compilers. And they've both kind of converged. So I think, these days, if you're writing a new language, maybe you'd pick GCC. I haven't really researched it, but back then it was the right choice, certainly. And you talked about like, the Rust team integrating GCC. And so there is I'm not sure, I think it's relatively new, a library from GCC called libgcc JIT. Even though it has JIT in the name, it can still do ahead of time compilation, which is what Rust uses it for. And so someone has written, I should explain briefly about how kind of like, a back end front end works. And so you have like the front end, which is like, language specific. You have like your Rust front end, your C++ front end, your Ada front end, your whatever Python front end. And then you generate some bytecode, similar to, a Java bytecode, but a bit more low level. And then the back end consumes this bytecode, which is kind of like, more or less platform agnostic, not really, but kind of close. And then turns it into like actual machine code. So for any given platform, any given features, et cetera, and performs all the optimizations for you. And that's just the really valuable part, is having both, encapsulating both the platform specific code gen, as well as the optimization passes, which are just a huge time sink if you want to do yourself. You would never manage to write any kind of real production grade compiler for a new language if you also wanted to also write all the optimization passes yourself. It just wouldn't happen, because there's been so many decades of research and optimization and development on these backends. So yeah. Then the idea is these days, Rust ships by default with the LLVM backend, but there are a few new backends in the pipe. And so the first one is CraneLift, which is a backend written in Rust. And I just mentioned how like, you'd never want to write your own, but the idea of CraneLift is not to be very optimizing. It's really meant to make code gen fast. And I think one of the surprising things about LLVM is that it's so good at making code that runs fast that it's actually not really specialized for generating that code quickly, right? And so there are plenty of options for making LLVM generate, less optimizations, but like it's just so baked in the idea that you would want optimizations that it's still kind of slow, which can be a problem if you just want to like iterate quickly and don't really need very fast code. So the idea of CraneLift, which is this new backend, is that it's designed for generating WASM. And obviously, if you're loading a web page, you really want to start with a very fast sort of baseline. You want to begin doing things as soon as possible, and then the JIT can kick in later and sort of like begin optimizing the hot loops. And so CraneLift is designed, even without a JIT, to get you from your source code to your bytecode pretty fast. And so by inserting this kind of like new backend, you can then kind of sort of in debug mode for Rust programs, you can reduce compilation time spent iterating, which is a pretty big deal. And so in the similarly, you want to have a different backend for CraneLift. You can have a different backend for GCC, which is the new thing. I'm not sure if it's fully production ready yet, but it did just get upstreamed in terms of like now it is supported officially in the compiler, and if there should be tests in the test suite for any kind of like CI is now making sure it doesn't break. And the advantage there is that GCC tends to support a lot more obscure platforms than LLVM does, just by dint of being much older. And so if you wanted to write for more obscure like embedded devices, I think you might want to look into GCC. Or if you're just like, philosophically, you just like GCC better, then go ahead. Because now it shouldn't be too hard to benchmark LLVM versus GCC code generation for Rust side by side. In the past, if you ever like wanted to like benchmark Rust code versus C++ code, you'd have to kind of like, if you wanted to be like a fair comparison, you kind of want to like, make sure you were benchmarking both Clang versus Rust as opposed to GCC versus Rust. Just because otherwise you might be benchmarking like, LLVM versus GCC as opposed to Rust versus C. And these days, you don't need to worry about that anymore in terms of like, assuming that the GCC backend for Rust starts to become more mature and becomes production grade. So it's an exciting time.
Yeah, I always get confused. Like, I understand LLVM and GCC are different, but then I get like, once I hear about Clang, then it's like, okay, well, this is like a front end to
I mentioned like
LLVM.
front end versus back end. Clang is just the front end for LLVM, and that compiles C and C++ code. So it's just a different front end. It's kind of like Clang is to like Clang and Rust C are both front ends. LLVM and GCC are both back ends. And then we often say, GCC to mean both the front end and back end, because historically they were pretty tightly coupled. These days, probably not so much, but we're still kind of being imprecise with terminology.
Okay, I understand now. Now it makes much more sense. Because I did some searching and I couldn't quite wrap my head around it, but now it makes much more sense to me. The one thing I wish, I don't know about if GCC can do this or not, but the one thing I wish Rust could do that Go can do is like compile, like at a Mac, I can compile to any platform I want with Go. I can say compile a Windows binary, compile Linux, etc. But Rust cannot at the current moment. But I've heard from somebody that it's possible, but there's some work that has to be done.
Yeah, you definitely. So that's called cross compilation, and I think Go makes it easier out of the box. Rust, you do need to like install. Like it's actually pretty easy in Rust, but you do need to do like you install like two things. It's like two cargo commands. You need to like both, and you have to like cargo install some kind of like tool chain for like the Windows platform that you want to target, and then at that point it will kind of go grab all the proper binaries that you'll need to actually link a thing that works on Windows, because by default it'll just give you your platform's own thing. So I mean, if Rust could do better if it shipped like every single so for example, like if you wanted to like just as a concrete example, if you wanted to like write for Windows and you're on a Mac, say, you're not going to have like all the right interfaces for actually producing Windows binaries, just because like you're on a Mac and it's like that would be more to download, more to upgrade, more to install every single time. And so if Rust wanted to, it could give you like everything. So you could like trivially out of the box like write Android code, Linux code, all those meta devices, that kind of thing. But it would just like greatly increase binary size in terms of the compiler's own binary. What you need to install every single time that you want to do like a Rust up upgrade. And so by default, it's just not there. But it's not really difficult to do it. You just need to install the right stuff, which really isn't itself very difficult. But we could do better here, and maybe in terms of shipping the really common stuff in every Rust distribution. Who knows? So it's a open question, but more could be done. Just kind of a question of whether or not there's demand for it.
Okay, so yeah, because I think you can do. There's two ways to target Windows. One is with the MS, I think, and then there's min GW, right?
Yeah.
So I could actually on my Mac, I could say install Windows min GW, and I can compile.
Yeah, that's one of the things where it's like I'm pretty sure. I mean, I again, not a Go expert. I assume that Go targets the MSVC version, or not? Sorry, actually the other way around. I assume Go targets the MinGW version by default, just for like licensing concerns. I'm not sure if like you can ship without sort of like intervention, or like if you can ship a single like binary or package distribution that contains Windows stuff, it might be kind of like one of those things where it's like you install Debian and it's like, do you want the non-free components? Yes or no? It has to be like kind of a separate decision just for legal purposes. But yeah, so like on Windows, there's both the kind of like free open source tool chain called MinGW. There's more than one, but that's the main one. And then the official one's called MSVC. And so depending on like what you want to do, you might need to use the official Windows if you want to like interface with certain software. Who knows? But I'm not a Windows expert by any means. So
okay, yeah, because that's the one part that is a little bit I think difficult for people to understand is like even for like for Linux, right? Even if you're on a Linux machine, you still have a choice between is it libgc and also musl, right? I think it's pronounced musl.
Yeah, so there are these are all, the idea here is that there are various interfaces to the OS that you might want to utilize, and there are different like trade-offs. And so like in the Linux case, like libc is sort of the way you do it, but there's different implementations of libc with different trade-offs. Like there's glibc is the kind of standard, but it's not especially friendly to static linking is the big thing. And so if you want like a fully self-contained static binary, which Rust binaries almost always are, with the exception of libc, just because glibc is the default. If you wanted a fully like statically linked library, then you'd want to use musl for that, which is like musl is a bit less like optimized than glibc, as far as I understand. Probably deliberately so, just because reduces code gen size, makes the binaries a bit smaller. You don't need to necessarily, if your goal is to statically link, maybe you don't want a huge binaries as a trade-off there. So who knows? And I'm sure they have their own development priorities. But yeah, so then there's definitely there's also more than one. I'm sure I think that I've heard of various Rust implementations of libc that are in various stages of completion. Who knows? I'm not sure if they're actually usable or not. But if you wanted to have no C compiler at all in there, for example. So yeah, it's interesting.
Okay, I think we're starting to kind of venture off kind of the original topic, like, but it's definitely interesting to say. It's totally fine. Okay, so we had something that was kind of similar to Go, in the fact that you had like green threads, you had GC language. Somebody came up with the idea, okay, let's try to use these academic ideas and using the borrow checker. I think you said before that there's actually the move semantics was already there. And then now, right, we went from OCaml, and then we able to compile the Rust by itself to its own compiler, right? And then I think sometime after that, there must be this idea of, okay, we have to start stabilizing, and we're going to have Rust Edition, right? Or I'm guessing Rust Editions didn't come out until after.
No. Yeah, let's. Right? Those didn't come till later. I think
if there's more in there, like let me know. Like I'm still trying to catch up because
Rust
I can talk about this. Been around for a long time.
In terms of there was definitely it's actually a really interesting sort of topic to so obviously, like I mentioned, Rust was extremely unstable, and to anyone who had known or about Rust or even vaguely interacted with Rust at all, you knew it was unstable. It had a reputation for being unstable, and so it was actually a really sort of interesting decision and of just sort of political will to be hey, we want to stabilize something. We could just remain unstable for years and years and years, and it would be much easier to experiment and to create craft the perfect language sort of in Amber of this very delicately perfectly aligned with every feature exactly orthogonal and well considered. But the idea is that you also want to make language that's not just academic, that's actually practical, that people can actually use. And there was so much demand, people wanted to use Rust. It was sort of there was just people were clamoring for it. And so finally it was decided hey, we know there's plenty of things that still are only kind of half baked. So, but we want to make something stable, have some kind of guarantee that so-and-so won't break. What can we do to work towards that? And this happened in maybe 2014 or so. Because I should say that the idea of, oh, we'll have a stable Rust was always even from when I first joined, was always 6 months to a year off. It was oh, soon we'll stabilize. 1.0 soon. And that really just it was only words for a very long time. And I think it was kind of leadership, just in terms of back then of the people who were kind of just the main luminaries were hey, we want to make this stable. What would it take to actually do it for real this time? And it was just an amazing effort of future proofing, because it was hey, we know that lots of things are going to change in the future. Let's put on our psychic hats and think, okay, in the future, what are we going to change? How can we leave ourselves the leeway to change it? What will need to be stabilized? What should be remain unstable? And so in this period, back then, I think famously Rust standard library does not is not very batteries included, right? There's I'd say that Rust library is very deep but not very wide in terms of what it does provide. It provides very good support for in terms of tons of convenience methods and various things. but like the modules themselves aren't like extremely like, there's not a huge number of them. There's no like HTTP library. There's no like various like, standards like, various like things that aren't just like, basic networking stuff. So like back then it was actually much larger. The idea was to provide some kind of like batteries included sort of thing. And it was just like, like we want to be stable. We are language designers and not library designers. So we actually have like very little idea of how to make good APIs. So for the moment, just take everything out of Stood that doesn't need to be there and just like put it somewhere else. Just like, and so like paired in the library, like drastically. And a lot of things got moved onto like the then like very fledgling creates.io. And it was around this time that kind of people began working on it. And so we actually just talk about cargo too, where it was like, package management. Kind of these days, the line is, we can get away with having a pretty small standard library because we have such a good package management story. And that kind of like, that developed over the course of years and years. Like Cargo was not the first Rust package manager. It's at least the third one. There were 3 prior attempts at it. And after the first 2, it was kind of like, well, these kind of work, but we really just, again, like acknowledging like, that they were not really like domain experts. They were better at languages than they were at package management designs. And so they just literally got some money from Mozilla to contract the people who had made Bundler. And they were like, please make us package manager. Here's our like, constraints. Here's how we're different from Ruby. And with this way, here's what we want. Here's what maybe you've learned things since you've written Bundler years ago. Just make us package manager. You have full reign. Give us a thing. And that's how Cargo came about these days. And so it worked out, I think, fantastically. And so fortunately, it was actually pretty easy to kind of like all these basic sort of half-baked standard library modules kind of got pushed out into Chris.io, having kind of like, I was the first real test of the distributed package management system. And then but in terms of the language itself, like there's a bunch of things where it was like, okay, like there were features that kind of weren't priorities. And so, for example, I'd say macros, right? So like, the pattern-based declarative macro rules macros, it's kind of been known for a long time that those are kind of like, not really ideal in terms of like how they're implemented. There were a lot of like deficiencies. And so it's been kind of like, even from Rust 1.1.0, it was like, okay, someday we're going to need to deprecate this. So we're not going to work too hard. We're going to future-proof kind of the syntax of this to make sure that we can change things in the future. And since then, actually, a lot of good work's been done to make macros closer to the ideal in terms of like what people wanted in terms of like making them integrate nicely with like namespaces. It used to be to use like a macro, you'd have to do a whole like a lot of kludgy, weird things, and it kind of worked really strangely in terms of like how you like they were always global. You have to export them strangely, import them strangely. It was just a big hack. And these days, it's much nicer, but there's still like there's so much more that can be done. And so the idea of like, macros 2.0, quote unquote, with this mythical idea of someday we're going to deprecate this macro system and make a better one. So like even back then, like there were things that were known to like, we could spend years and years just iterating on this and developing it. But we're not going to. We want to have we have a great foundation here. We want to make that stable and then like continue. And so I think really it's just a miracle really that it worked out as well as it did. Like lots of very smart folks just sat down, thought hard about the problem, and then just by some miracle managed to make it so that like we really haven't had a lot of friction in terms of like not a lot of regrets. Like I'd say that like there are a bunch of small things, right? Like there's all kinds of like like interactions that you can't foresee, or that kind of like just there's so many features that like interact with other features, but many of them have managed to been fixed over the years, especially with additions, which we'll get into in a second. But like really, none of the major features of Rust have caused that much trouble. I can name like some, like I think like destructors are like the biggest like sticking point, where it's like, well, like various, you can think about like, like should the drop method in a destructor should take like, a mute reference to itself. That's kind of a weird thing if you think about it. Like when should they run? Should we have like better support for like guaranteed like destructors? Kind of like should like, are they like guaranteed to run? Like should we have like linear types where you must use them? Like, in terms of like explicitly you can reorder them. I can go on for days, but that's really the only thing I can think of in terms of like regrets or like would you do it differently these days. And even then, like, alternative designs aren't really extremely clear of what you do differently. There are always trade-offs. So yeah, that's like and it kind of it just happened. Like, in like early 2014, the idea was we want to become stable, and then lots of folks pulled together like heroic efforts to do it, and it happened. And it was kind of just like, wow, this actually worked, and now people can use language, and it's kind of like, and it's a double-edged sword because you once you're stable, you can't do a lot of things. A lot of things get a lot harder to develop and change, but you get so many more users that like feedback comes so much more quickly. And I really think that like Rust's like early days, like because Rust was developed in the open, anybody could come, use it, comment on it. That really solved so many problems that the reason that Rust kind of has so few regrets these days is because of that like years and years long process of like open development, of getting feedback of what worked and what didn't, getting it used in 2 very large projects like this. And it's a real success story of open development. I think kind of like I want to like contrast, not like I mean a mean way, but like I think when Swift came out, like they were like kind of in very like Apple fashion, very like quiet for a very long time, developing it in the closed system, and then after it came out, it became stable very shortly after public release. And then in the first few Swift releases, it kind of changed a lot, which I think a lot of those things could have been averted if they had just been developed more in the open, just because they weren't using it like with enough public feedback. Because they're Apple, very secretive, famously. So I think Rust avoided a lot of those problems and has like had a lot less tumultuous sort of like breaking changes than Swift has. But we can kind of like segue from that into the edition system, which is over time kind of like, especially with the first edition, the 2018 edition, like there are like some things that you want to change, some things that you want to add, and then also just like even adding in mechanisms that will allow you to add things in the future without the need for editions. That's one of the themes of editions. And so I could talk more about that, but are you tired of listening to me talk for now?
No,
I guess I can just go on for so long about any of these topics.
Yeah. There's sometimes I want to ask questions, but at the same time, like I don't want to interrupt your flow.
I mean, no, feel free. What do you want to do? Like we're just wrapping here, so.
No, I mean, you mentioned it. Like I heard this from John, I think, and he made this fantastic point that like, yeah, Rust has a very, very small standard library, and like you said, like there's a reason for that, and that's because like with a small standard library, like if you ever want to break something, like you're less likely to have to break something, right? If you wanted to do something. So like, for instance, like I've been working with Python recently, and the logging module doesn't follow the way you should write Python code. It's not very Pythonic. But you look at like, why don't they change it? Well, it's because they don't want to break backwards compatibility. And so with Rust, because there's supposedly such a small standard library, that this kind of issue wouldn't happen. You just have to just pull in a new crate and, bam, you can make your breaking changes, right? You can do semantic versioning. You bump your version up, and then you should know that you're ready to be making some changes if you want to bump up your version. But like at the same time, like I'm looking at like the changes that are coming into standard library, and I look at the standard library, and I don't feel like it's very small. Like if you just take a look at like result, I think it's result. There's a lot of like there's cool stuff there, like with the like functions that you have. So like you can say like dot is okay, I think something like that. Like there's a lot of like things that I think are like not really, I mean, they're more like good sugar, I would say, rather than like, okay, this needs to be in standard. And like there's always changes and new methods and new things added to Rust all the time that like when I hear that Rust is a small standard library, I just don't feel like it is.
Yeah, it's kind of on the surface, it's easy to think that way. So if you're brand new to Rust, you're going to come in, you're like, where's my HTTP library? Where's like, this or that? Where's my like regex library? That kind of thing. And it's just like, well, go to Chris.io and get it yourself. Which some folks like don't really, if they're coming from a language that doesn't, has it built in, they're like, they grumble a bit. Right. But like, that's kind of like the surface level. That's for people who are like, new to Rust or on the outside. Once you're into Rust and you've actually like looked at the Rust documentation and scrolled down at any of the like module pages or type pages, and you realize just how many convenience methods there are, like especially for things like, option and result, because they get used so much. It makes sense to kind of like focus your efforts there. Again, like the comparing Rust to a very deep as opposed to a very wide sort of library. So like if you're just like not really used to it, you can't really see below the surface. You kind of like but once you get like try to dive down and you see just how deep it is, like the volume of functions there is pretty comparable to what you'd find in like a more batteries included language. Maybe still not Python. Python's both pretty wide and pretty deep, I'd say. But also Python's, like you mentioned, like it's a very old language. Like, I mean, like folks like don't really tend to understand like how old Python is because they probably got into it like around like mid 2000s when it really took off. Kind of like, heard a lot about it when the Python 2.3 split happened in like 2008 or so. But Python's been around since the 80s. And it just took a long time to kind of like just get off the ground. And so like many things, things weren't Pythonic, but have been written in a very like Pythonic fashion at the start. But that's kind of because, what is Pythonic changed over time. Features didn't exist back then. And so Rust has the same problem where it's like, if you have this library, here's this API, but we have like a new feature. And let's use const generics as an example. Like, that obviously didn't exist for the longest time, but like it's very useful in terms of like writing APIs that can leverage const generics. And so these APIs have been stabilized in the past like, year or so and it's been usable. But like there is this kind of divide, and the longer you go, the more features you introduce, the more obvious this divide gets. And so you're right in that like, having a smaller library reduces this risk. In terms of like, the old joke is, the standard library in any language is the place where code goes to die. Because at that point, like it's so baked in and so like universal that you just can't change it anymore. And so it's a double-edged sword, right? Like there are a lot of reasons to put more things in std. But it's also like, a much increased maintenance burden. And so anytime that you want to add new things, it's just a really big discussion of like, well, should we add this? Like, can we add this? Can we support this forever? So, yeah, I mean, I would like to someday write like a sort of guiding document on like the criteria to consider when you want to put a thing in std or propose a thing in std. Because there's like, again, the biggest advantage, I think, of the standard library is that it is standard. And so like nobody needs to do the research. No one needs to worry, like, is this lib still updated? If you're brand new to like the whole like ecosystem, do you need to worry about like, okay, like maybe people who are here for a while know that the like regex maintainer or the city maintainer is like trustworthy. But like if you're brand new, do you know that? Like if you want to trust just the language, like, the trust surface is lower with a large standard library. It's easier to distribute because you have like fewer things to compile afresh every time. If you have like, pre-baked, you already have the standard library binary on your computer. And so there's just a lot of advantages to putting things in std, but also a lot of trade-offs. So I don't know, like it's a great topic. I do like a bunch of volunteer work for the libs team for Rust. It's my main like contribution these days is doing libs stuff. So it's a lot of things to keep in mind. Just a lot of I don't know. Philosophically, it's fascinating.
No, it is. Like I've been paying attention to what's going on in the Elixir community, and like, yeah, once you add something, then it's like, yeah, you can't really take it out. Like you can deprecate it, but like when do you take it out? And also like, yeah, and also you have to maintain it, right? Every single time you want to make a change. So
yeah,
it's tricky, right? Like what do you do? And so a lot of times you hear no, right? No, we're not going to add this.
Yeah.
But then sometimes like I see them add things. I'm like, well, why? What's the point of this? Like greatest common denominator for something. Like I even to this day, I still don't get it. But, I guess it's like a basic for certain types of math or cryptography. Okay, fine. But should that really be in standard library?
The great thing about Rust development is that all this happens in the open. Like there has to be an RFC or like for small things, you can just like make a PR if you want to add like a single convenience life thing. It's like a simple sugar for everything. But it's all documented. It's all out there. It's all in the issues tracker. So like you can go out and read it. And like, again, like these are all just people, like, right? So people who make these decisions, they're all just like, they're all people. They're all like, making these things. None of them are infallible. So if you like disagree with a thing, maybe you're right, maybe you're wrong. But like the idea is that it all has to be discussed somewhere, and you can find the arguments and maybe disagree with them. Who knows? But like people like ask for these things, and if you want a thing in there, the great thing is you can just ask for it and figure it out. So it is, you can. I encourage folks to propose anything for inclusion in std, just because like I think having a bigger standard library is like, even though it increases the maintenance burden a lot and also the cost of changing things, it is just like such a good thing in general, because there's so many other good effects that like, even with really great package management, you still benefit so much from having things in std. But I mean, obviously people can disagree. There's a lot of philosophy involved.
I also thought it was quite fascinating that like I never knew this, that cargo was created by the people who created Bundler, because I came from the Ruby side. So it's very interesting. I would have never guessed this. And cargo is fantastic, but I'm also kind of curious, like, why did they decide to use TOML? TOML is like, why not just use YAML or something a little bit more standard, right? TOML is, I
Mm,
mean, it's kind of like a weird mix of, it's to me, it's just like YAML, but it's still like, why TOML? Like, what's the benefit?
you have to ask them. I mean, like obviously they came from Ruby, they knew about YAML, and I think the problem with YAML is that it's just like it's if you just want a simple configuration format, YAML is just too large. It has just too much that you don't really care about. So it just like TOML is a much simpler, smaller language than YAML is, and it's just like less surprising in general. So even though it's less expressive, that's kind of the point where TOML is. Even TOML, I'd say, is like more than you need for Rust configuration. Like you don't need date time stuff in there, for example. Like you don't need a first class datetime thing. You don't need a lot of this like various more obscure data types or like ways of defining more than a way of defining like arrays, that kind of stuff. So honestly, I would like a more like a smaller language for like cargo files, cargo dot like ROML, kind of like just like a small syntax over just having like hash maps for like here's a key, here's the value, it's a string, there you go, all you need. But obviously, like the topic of getting init files and like configuring and specifying the format of init files has been going on for decades. People have been configuring things via files for like 30 or more years. So it's I think it's again like it's more obscure than YAML, but also just more simple. And I'm not mad at it. It doesn't really get used very much outside of Rust. Like there's also JSON. Obviously, it's like JSON but less verbose, easier to type. So I don't know. I'm not too worried about it, but yeah.
Yeah, it's okay. It's just like, what the heck is TOML? That was like my first thing. Like, and okay, I think like another interesting thing is like I do like, it's interesting because like the first thing, like when you start off writing Rust programs, it's okay. All right, this is the name of the crate, and then this is the version number. Okay, cool. But then now you have extra things you start sticking in there, which is even more interesting because now you can turn feature flags off and on. That is another weird thing. Like, what was when did this stuff kind of come along? And like, like the one thing I could never seem to figure out is like, Serde is supposedly kind of one of the outlying crates where you actually have to turn on the derived macros, as opposed to usually everything is on. You have to turn things off, right?
Yeah. So in terms of that's feature flags, and so like obviously like cargo. It does two things. It's both package management in terms of like, it gets all your versions for you, it pulls them down, that kind of thing. But it's also a build system. And so it has all this configuration that you want, like how do you want to build things? And so the idea of features came on pretty early in cargo, but they weren't really very widely used in like casual libraries, just because like, it's a bit more of a pain to like actually define like what a feature is in your library, as opposed to kind of like saying, hey, you get everything all by default. But the idea for doing it, especially for like a very large and well-used like library like Serde or regex, is that it can really reduce compilation time. And that's the main reason. It's because like obviously if you want to have like spend less time compiling, you want to compile less code. And so like because Serde or regex have all these like maybe you just want to match like a single thing. Like for regex, maybe you don't want Unicode. Maybe you just want like maybe you only want like ASCII stuff, right? Maybe you don't need like full Unicode support for regexes, or for like Serde, maybe you're not using derive. Maybe you're just writing all the things yourself, right? And so in this case, you can have pretty big performance wins by not using those features. In terms of like by performance, I mean just in terms of compilation time. So for iterating on your project, if you don't need these, turn them off. Or in the case of like, Serde or regex, I think maybe sometimes like there are default features that you can then like, you can say opt out of all default features and then turn on kind of like piecemeal or a la carte. Like just want these. So it can kind of be like a hybrid of both convenient, but also if you want to dig into it, it can be faster to compile. Yeah, and it's one of those things where it's just there for the sake of compiling this code. That's pretty much it.
And there's no like tree shaking within Rust where you could just see that you're not using these things.
Well, so there's when you compile the final thing, like the final binary, LLVM's job is to optimize out things that you aren't using. So like again, like it's all like statically linked, and so like if LLVM is doing its job, there shouldn't be any like functions that you're not using in the final binary. So like tree shaking, like there is in like JavaScript, isn't really the same thing. But it's still like if you're doing debug mode, it might not be doing optimizations that like actually eliminate things, and so it might take longer. But even in debug mode, like it still needs to parse and type check all your dependencies, right? Because like if you have Rust, you say, hey, here's a library, compile this. I want to link to it later. Compilation happens in stages. So it has to say, okay, I want to compile this whole library, and then we use it later, but it's compiling the whole library first, and then only later on does it realize, oh, you're only using a single function from this library, and so you can't, go back and uncompile that library. And so the way that you say, tell Cargo to ignore code to not compile certain parts of the library is use features. And you could also just you can imagine people who make these libraries just like splitting out the libraries into individual libraries. And so I think like Tokyo does this where they might have both feature flags, but also they have like totally separate libraries. So if you have the basic Tokyo crate, I'm pretty sure that what it does is it is made up of like tons of smaller crates. And so if you have all the features on, it will grab all of them. But if you want to only use a single crate from Tokyo, you can just not use Tokyo and just use like a Tokyo dash whatever crate. So it's a different way of doing the same thing, sort of like achieving just smaller compilation overhead for like iterating in debug mode. But ultimately at like an optimized binary, it shouldn't make a difference in terms of the performance of the binary.
Well, obviously this whole feature came in after Cargo, right? Was it like very close to it, or was it actually involved within Cargo creation process?
I think Cargo features, it's a kind of a bad name because kind of like you talk about the features that Cargo has and the feature of Cargo called Cargo features. But Cargo features kind of came pretty early on. It was like late 2014, I think, was when before Rust 1.0. So, but obviously there were libraries that existed before 1.0, and so like the idea is you want to like move these libraries over, and not all of them were like comfortable using Cargo features, and some just didn't really see the point. And the whole push for like making Rust compilation faster has kind of been an ongoing thing for years and years, and so it wasn't as much of a concern in the community for a long time. So we're still working on setting the norms for, I think we can do better in terms of messaging where it's like, if you're making a big library, it can help a lot of folks if you like at least give them the option to turn off some features of your library, especially if you can pinpoint so for Asserty, the derive macros can be a performance problem if you use them a lot, right? And so it's kind of just these things that we didn't really understand for a long time about Rust, because you write this language, you use it for a long time, but you don't really no one's the master of it because it's still so new, right? And it's until a while after 1.0, no one's really going to call themselves a master of Rust because you haven't mastered the idioms because there are no idioms yet. You're still making the idioms. And so it wasn't until we had more experience to really know how best to structure Rust libraries that we can say, okay, yeah, you should be using features here in this case, but in this case, it doesn't actually matter over here. And so, yeah, it's an ongoing thing. Rust is still a very young language.
Okay. Yeah, I mean, I think we can keep going on and on. Is there like a certain part of, like if you were to name a couple of places that were like huge milestones within Rust from the beginning to now, like what do you think those would be that are really instrumental?
I think huge milestones, like I mentioned. So there was I'd say in both technologically and socially, I think the milestones were Graydon starts writing Rust and writing up all his design documents and noodling on the basic compiler. That's a 2005, 2006 sort of area. Eventually, next milestone is he talks to his employer, Mozilla, and says, "Hey, we're doing this. I'm doing this thing." And then they say, "Hey, we want to pay you to do this." That's milestone 2. Next milestone is, I think, Graydon was just in the office at Mozilla somewhere. He, I think, flew into a different office because I think he's from Canada, and he was in SF or something. And then he was giving a presentation on Rust. And then Patrick Walton, one of the really formative early Rust developers, was just walking by in the hallway and saw him talking about this language and just was like, I want to work on that. And so Patrick Walton getting involved was a huge milestone. And then after that, various other folks get involved too. Very important. I don't want to minimize their importance, but kind of there's a lot of folks over time who get involved. And then at some point, Nico Matsakis kind of starts pushing for the idea of a borrow checker and convincing Graydon that it can work. And Graydon's still kind of skeptical, but he gives the go ahead, and it works very well. And so there's a lot of still open questions, and it evolved so much in those first few years. It's hard to say, this is the borrow checker. But it's an ongoing process of how do these features work together? How do we because this is the first time anyone's really tried making a production language that uses these concepts. So how do we make it? How do we design it so it actually works the way we want it to work in terms of being memory safe? How can we test it and make sure that we actually can keep these promises. How do we make it ergonomic, and how do we teach it? How do we like invent the terminology that people can use in documentation? How do we actually, actually then write documentation for this? And so it's just a big, long, ongoing process. I'd say various other features kind of like come and go. Like, for loops are kind of like, they used to be like more Ruby style, and they started becoming more like, C++ style, but still pretty different from C++. Also like closures too, becoming more C++ style was kind of like one of the long steps towards making Rust not a GC language and just being very statically determined. And obviously like the 1.0 push happened. The idea of like, the Rust additions came in there at some point. The Rust Foundation getting set up for like, being kind of like self-sufficient on its own as a legal entity. I don't know. There's so many things I could talk about in terms of just like really good milestones in terms of like the language itself, and also like, like cargo, right? And like Crace.io, all of these things. Like they were like, Rust governance changed over time, where it used to be kind of like just Graydon, and then like just Graydon and Patrick, and then just Graydon and Patrick and Brian and Nico. And then over time, like I kind of like coalesces into the idea of the core team. And then over time, the core team kind of like, delegates power to like sub teams, and like writes up a whole like charter for all of these. And like what sub team should we have? We have like language and libs, and we have the tools, and then those kind of like, evolve to the kind of like, delegate power to the working groups for experimentation. There's the whole RFC process. There's like just so much in terms of like that it takes to actually have a self-sufficient, self-sustaining project over time that can be resilient to like people leaving, people joining, onboarding new folks, like, keeping the language running and stable over time, like Crater becoming a thing, right? Like, so you can like, Crater is the tool that lets the Rust developers like check against all of Crace.io, all the public code out there, to make sure that a new change hasn't broken something, which is like, oh, what a brilliant idea. Everyone should be doing this. And just the idea of, even like, the developmental, like, there was a long time when like, you just kind of like, you were allowed to just push whatever you wanted. You had the commit bit, just push whatever you want to the GitHub repo. And like, it ended up like breaking a bunch of stuff all the time because everyone was doing things. The tree was always on fire. And one day Graham would just like put his foot down, like, we will never again push anything to master that hasn't been totally integration tested. And that's just like, been the rule ever since. And so like, it just keeps everything working together. It's just a great way to like, in one way it scales, it's hard to scale that way because it takes so much longer to actually merge a thing, but also it just like over the long term, it saves you so much time of like not like figuring out, okay, what broke, how did it break, who broke this, who can fix this, what to revert, how to like, get back to actually anyone getting any work done. It just saves so much time in the long run, even though it's kind of a pain in the short run. Like it just like, you can point to any of these just like very formative developments as being like an important thing to Rust's history. Milestones just even begin to like describe, where it's like we can talk about like, like what kind of milestone you want to talk about. So I don't know. I can go on and on and on, and I will continue to unless you stop me.
No, it's great. Like, you're naming a lot of things that maybe I think probably most people don't even know. I think let me ask you about another kind of milestone, although kind of a little bit sad. Like, what do you think about Mozilla letting go of a lot of people, right? Was that like a positive milestone, or do you think it's a negative milestone, or maybe
like,
it's
I don't
yet to be
know.
seen?
Like, again, like you don't like seeing a guy like organizations like Mozilla who's like, done a lot of really good things, like, being on hard times. But I mean, honestly, the fact that Mozilla is still around, to be honestly, I thought Mozilla was going to like fold and go under like years and years ago. Like, it was like 2011 or so. Like, I really, I understand the appeal of like having like, an open sort of like web platform that isn't controlled by any one entity. And so like, I was really like, excited for like helping out the Mozilla project to like, oh, this can be like, some kind of like differentiating feature in Firefox. I use Firefox still to this day and have for like, since like 2005 or so. So I really wanted to help out. And so I was happy that I could like, help out Rust as part of helping out Mozilla. And so I'm actually impressed that they're still around, still doing things. I still get to use Firefox, and I'm still like, I like it a lot. I'm really enjoying it. I use it on mobile, whatever, desktop, all this, every platform. But I mean, like, if you to see them like kind of like, on hard times, unable to afford having like, all these R&D folks. But at the same time, like Rust has gotten big enough that anyone who got laid off was able to find work pretty quickly, and they're still like, I don't think you worry, oh, can they still work on Rust? Can they not anymore? But everyone that I've seen has managed to find full-time work, still being able to contribute to Rust either full-time or at least large portions of their time. So I don't think Rust has suffered for it. And also, it finally pushed people to really advance the idea of the Rust Foundation, which is a good thing to have for like having the legal parts of the language in terms of like the trademark, the copyrights, all under the control of like an impartial corporation, a legal entity that is. So I mean, yeah, it's in some ways it's sad, but like Mozilla still uses Rust. They still contribute. They're still a member of the Rust Foundation. They still use it in Firefox. And they're actually, making it using it more than ever in Firefox. So they're still working on, various parts like web render, and I'm not sure what their plans are these days. I'm less involved, but I mean, in terms of like Rust itself, it really hasn't ultimately changed much. So, I mean, I think it came out as well as it possibly could have, and now, in the event that anything does happen in Mozilla in the future, it's not going to be a problem for Rust. So actually, I saw recently that Chrome was looking at like, just investigating what it would take to integrate some Rust stuff. So it's like, even beyond Mozilla these days or Firefox, and there's so many other, things using Rust that it's hard to imagine that no matter what happens, Rust wouldn't have support from somewhere, right? So you want to like, as like prior art, you want to say, hey, like, let's look at this other language over here. Let's look at, Scala, let's look at Clojure, look at any of these languages that like, they all like, many of them aren't as like, don't get used in this area, but they do get used in this area. So I don't want to like be unfair. Like Scala, obviously, I think Scala probably gets used more than Rust in general, I'd say, but like more in the enterprise space and less in the open source space. Even though there's plenty of open source Scala projects, but like even then, like Scala still thrives, right? It still gets developed. Plenty of like people writing libraries and tools for it, Clojure too, all these things. And so like Rust, even if it shrank, even if like Rust usage shrank, Rust will still be around. People will still use it. People will still be able to like work on it, develop it. So there are like, consultancies using Rust for various things and that can, afford to fund developers for it. Yeah. So I think that Rust is in a pretty good place these days in terms of having sponsorship and still having a very healthy, active volunteer community. I mean, there's still so many volunteers working on Rust all the time. Like if you don't like, get involved, you really have no idea how many people working on Rust are just like doing it out of passion. And so it's the idea. I love that the culture that Mozilla sort of like initiated, where it's like volunteers are so empowered to do things, and everything has to happen like out in the open, transparently. There's like so many discussion platforms that are just like free to use, very public, that it all really is amenable towards encouraging a volunteer culture. That people can like, if they want to help out, they can. And if they want to, get paid to do it, they convince a company to pay you, and then you can keep on doing it. That's actually, that's where I am these days. I've been volunteering for so long. I kind of like want to start like, finding ways to get paid to like work more full time and like have to, take less time off of working, on Rust to actually get paid doing non-Rust stuff. So, because I kind of like, I have a very humble lifestyle because I like to volunteer so much, not just on Rust, but, many projects. But Rust is my my main passion. So we'll see how that pans out.
Okay. Yeah, I was thinking like this is kind of a little bit nice because like I feel like Rust has kind of had some slowdown because it was like, okay, this is, not really, I didn't say it's not really open source, but it's like this is a Mozilla project. This is not like, like it's one of the few open source things that I think has a company's name slapped on it. As opposed to some others, because a lot of others I think kind of just came out of personal stuff and then maybe later on got sponsored, as opposed to Mozilla, which seemed like it was just as opposed to Rust, it seemed like it was just out of the gate when it became popular. It was already really deeply invested by one company, Mozilla, but now it's like, okay, maybe starting to become more of an AWS project now because they've been stacking up on a lot of Rust people nowadays.
No, I wouldn't. I think these conceptions, like it's honest that like, I can see what people would think that, but as far as people are involved in the project go, like let's say, historically, like Mozilla, right? Like from the early days, Graydon was extremely adamant that like Mozilla, it was not a Mozilla language, right? Even though like at that point, all the full-time employees were all Mozillians. But still, like if you went to the Rust website, there was no like Mozilla logo. There wasn't even like the word Mozilla on there anywhere. Right. It was always intended to be an extremely like, independent sort of project, which I think worked out really well in the end. Right. In terms of like the idea that like, it's independent. People didn't like take it for granted. Like when finally they had to like, separate from Mozilla, it was not disruptive just because like for years and years, like people have thought of themselves more as Rust folks and not as like, a subsidiary of Mozilla, but Rust was its own thing, sort of just like being sponsored by this company. And like, I don't know about like AWS, like I'm not sure like where this idea comes from, but like there's not there's not that many AWS folks in terms of like, the overall number of people contributing. There's definitely some. Like Nico, for example, I think works at Amazon. I think it's not. I think he works on the Rust team, which is a separate thing from AWS. It's just like its own little department, which is great because Nico is like brilliant, and just like giving Nico the chance to like sit and think hard about Rust all day is just like so good for like Rust. Nico is Rust's the main like type system guru and borrow check guru. So just like we just need him to sit and think hard about things and then write up his thoughts, and then people can implement it. And that's just like great having someone who can do that. But like I don't really see Rust as an Amazon project or as anything project these days. It's just the Rust project, and it's I don't know. I think people get. I mean, obviously, like, you can criticize companies. I certainly do. I criticize Amazon all the time, Facebook, Google, all these things, Apple, Microsoft. Like I can go on. It's probably off topic about like the morally questionable things companies have done. But I wouldn't say that any one company controls Rust. And even then, I think that if you understand the realities on the ground of what it means to make a language, you see there's really no advantage to owning or trying to wrest control of a language. Languages they don't make any money. They are mostly just there as good PR. They're charity cases. In a lot of senses, kind of like you can, no company can stop Rust from being open source. It's just completely infeasible if you understand anything about licensing and copyright assignment, which has never been a thing in Rust. So if you've ever written a single line of code that's in Rust now, you still own that line of code, and nobody can ever change the license that you issued it under. So Rust will always be open source. It'll always be open development. And I think the idea is people kind of don't understand the distinction between the foundation and the Rust team. The foundation is just there to like hold the trademark, and to like if like people want to donate money to Rust, they can then like direct that money towards like, hey, we'll hire a contractor to work on this one feature, right? But the idea of what gets in the language and how to design the language, that's all the Rust teams, and those are all the exact same. Like they're totally distinct, independent entities from the Rust Foundation. They're not subsidiaries. They're just volunteer organizations. They all have their own charters, their own membership. They all have their own like ways of working. Some use Zulip, some use Discord, some communicate over here, some use like they have their own like GitHub repos for like organizing their own thoughts. They're all extremely independent, and they all do their own things. There's not really any like focus. Like the Rust has a core team, but the core team has long since devolved a lot of its authority to the like the sub teams, say the language team, the library team. There's like there's almost unthinkable that any one company would like find a way to strong arm any of these teams, like any one, let alone all of them. And even then, like, the Rust folks, I mean, like, you have to trust me here. Obviously, you don't need, you don't know me from Adam, but like still, like, the Rust folks are all pretty ideologically committed to open source, and they're all pretty open to the idea of like, of disclosing who they work for, and like making sure that, okay, no one company controls them, like, a majority of any people in the team. And even then, like, and Rust teams work by unanimous decision, not majority decision. So you'd have to have a company take over every single developer on the team and have like, people be complicit of like, oh, we won't add anyone on the team who isn't from this company. Aha. And that just wouldn't happen. Right. So I think it's just people being paranoid. It's reasonable to understand that. But like, as someone who is involved in the project and has seen these people and has met the folks and working on it, I'm not worried about any one company taking control of Rust. That's just not how it works.
Okay. So I think a final kind of way to sign off in this podcast, because I took quite a bit of your time already, would be, like based on where we are right now and RFCs and kind of where we've been, like, do you have an idea about kind of where the future of Rust is actually going to be now? Like anything immediate or anything in the far future?
Yeah. So like I could describe, like, so I mentioned before, how the idea of Rust is like, you have a lot of features that are only half baked that you like before 1.0, and it's like, what do we do about these things? We want to someday support this feature or this pattern, but we can't do it right now. We don't have the time to even like bother investigating or designing or implementing this kind of thing. So there have been a lot of unstable features for an extremely long time that have been kind of like slowly worked on. Either, the low-hanging fruit has all long since been plucked, So these days, the long-term features are all things that have been kind of like in discussion for years and years and years. And so like sometimes like the way that like Rust works, again, like there's a lot of just like volunteer stuff. Like there's not really anyone handing down directive like, hey, you must work on this. It isn't a company. There's no one to fire you. If you want to see a thing done in Rust, basically you or someone needs to actually care about it, and then they go and do it, right? And so someone needs to be passionate about some topic or like have like something they want to do, and then they do it. And so in this case, I think they got like was of that kind was const generics, and so the idea of like constant evaluation had to improve a lot, which has like it took over years and years and years of like heroic efforts of like writing all new const code, unifying various like primitive prior const evaluation engines in the compiler, designing various things that kind of like were only half designed before, adding them in ways, stabilizing them in ways that couldn't break old code, and just like reams and reams of testing that required. And so finally, after all this, we have kind of an MVP of const generics. And that's kind of how things work these days. Is you spend a long time figuring out like how should a thing work? How does it like meet the needs of like Rust in terms of like it needs to not sacrifice memory safety. It needs to be extremely fast. It has to optimize well. It shouldn't regress compiler performance as much as possible. That kind of thing. It needs to be easy to maintain. It has to be possible to review, obviously. So how can we like add it piecemeal? And so in terms of the long-term goals, I'd say one of the more hopeful things is generic associated types, which are kind of like it. You could do an entire podcast on what this means, but the gist of it is that currently today you have a trait, you could have an associated type in that trait, which is useful for a variety of ways, but you can't use a generic inside of the associated type. And then in the future, you should be able to. And this solves a lot of problems. Like it sounds very simple. And it's great because it's very easy to teach. Like if you know Rust, you probably know associated types, and you probably know generics, and it's like, it's just put them together. There you go, easy as that. But the implications of this in terms of both like what it takes to support in the compiler and also the new patterns that emerge from this are immense. And so it's been like a long time coming, but it actually involves rewriting Rust's entire trait resolution engine, which is kind of like, from 1.0 is kind of just like an ad hoc like thing where it's like, we don't really know like the best way of doing it because we're kind of like forging new ground here, forging a new path. And so we'll just kind of like do our own thing. And then over the past few years, Nico has been bringing up like ways of formalizing how to, resolve traits properly in the compiler. I'm kind of using jargon here. I'm sorry, but we only have time for going into it too deeply. But it's kind of like it's becoming more and more sophisticated in terms of like how can we enable new patterns in ways that we can guarantee that it won't like cause code generation bugs or violate memory safety, prove that it actually works and solves the problems we want it to. And so that's been forthcoming for a long time. And that's finally getting to the point where I think that they can turn this on. And in particular, this is one of the, if you care about async code at all, this is one of the prerequisites for having async methods in traits. So be able to call kind of like, async methods in context. So that's exciting. And that's a cool thing coming in the future. But yeah, there's just a lot of like really old things that are the high hanging fruit, I guess you'd say, where it's a lot of really difficult to design and implement features that are forthcoming. And I think maybe like, the perception that like Rust development is slowing down, I don't really see that. Like if you look at the number of commits to Rust over time, like I don't think it's declined in the past few years. I think it's kind of been the same. Like every week there's like a few hundred, because I go read tour every week and there's always like, 100 commits, 200 commits, 300 commits per week. And I think the idea is that there's fewer user-facing things. One, because Rust is just getting more mature, so like things just naturally slow down, but also because all the things to get work on these days are all extremely difficult in terms of like, they're the features that no one has wanted to tackle yet because they, were so much more difficult than the other features that you could be doing. So just in terms of prioritization, it had made sense to work on the easier things, and now we're in a state of Rust's life where now it's time to work on the hard things. So things to look forward to are generic associated types, improved const generics. That way, someday, like I mentioned before, macros, a real macros 2.0 in terms of like solving the problem with macros 1.0, like finally once and for all, which is coming along. What else? Just I don't know. It's if you wanted to see the future of Rust, go to the RFC's repo, look for the open. Actually, sorry, go to the Rust issues uh, repo in the Rust issues tracker, and just like search, like narrow it only to tracking issues. The tracking issues are 4 RFCs that were accepted, and then sort by reverse date, and then see the oldest ones and see, okay, what might be coming in the future. And there's like, a few hundred of these. And it's kind of like, well, we just need somebody who cares about any of these to push them through. Like some are like, even like, many of them are implemented fully or half implemented. Some just need folks to like really care about like testing it, write documentation, and stabilizing it. So the right thing about Rust is that the future is whatever you make of it. Like there's so much that could be coming. It just requires someone out there listening to this right now to say, hey, I want this feature. I'm going to go be the one to do it. And you can. So Rust development, it's pretty cool.
Okay. Yeah, that's very true. That's kind of the really nice part about Rust is that it's really all out in the open. And yeah, you can always cast your vote and say what you want to say. So it's both good and bad, right? I mean, the bad part is that you have to listen to all the voices, and there could be a lot of voices coming through. I think that could definitely take some time, right?
Mm-hmm.
You say so much before, but so little about this. I'm surprised you don't have more to say about this, because I mean, listen to people's opinions about this. I mean, this is like the one place where we're talking about opinions, right? Like there's a lot to say. Mm-hmm. I mean, people sometimes just don't want to change their opinion, and they just say, no, this cannot be in, or this has to be in, or this needs to be changed. This is not good enough. I'm just surprised at how things can even get through.
Yeah. I mean, from where I stand, like I'm the kind of person where it's like, I like having a smaller language. I hope the language stays small. I mean, people think, oh, Rust is a big language. I'd say Rust is actually kind of like a medium verging on large language. I have seen way bigger languages than Rust. Rust is, as far as I'm concerned, actually pretty elegantly designed and orthogonal. There are some things I'd change, obviously. There's nothing's perfect. I have my own bugbears, but I don't want to get into that right now because, like, various things are, never going to happen or are nowhere close to ever happening. Maybe I designed those things myself. I've written a few RFCs in my day, so I know how to change things and know like what is like likely to be changed or implemented in the future. But yeah, there's like it's a very open sort of thing. Like I think right now my focus is mostly on, like I said, I do lib stuff these days because I think the libs is really where a lot of the like innovation is happening in terms of how do you evolve a language in a way that's kind of like, it remains backwards compatible. How do you add new stuff conscientiously so it doesn't break old stuff? How do you like, reveal this in documentation and, to make it easier people to even like read the code. So like Rust doc, very important for these days for developing just kind of like all the tools. And so I think right now, like, if you want to talk about the future of Rust, it's the tooling. So you can use all kinds of like, tools these days. So, there's obviously Rust Analyzer for IDE support. Rust docs always getting a lot of new stuff. Cargo getting new stuff. Just like in terms of like, just other tools, tools for, what's it called? Loom is a tool for like testing that your concurrent code all works out well. John, you talked to it before, you mentioned, has a really great video on how Loom works, I think, and how to use it and what it tests. There's Miri, which is the engine that underlies Rust constant evaluation code, so constant generics, but like Miri itself is a tool with a much larger scope. It can also execute code sort of like statically, sort of like imagine kind of like Valgrind for C++, but for Rust instead, and like tailored to Rust, so it can detect a lot more stuff than Valgrind can. And it's great for like, testing your unsafe code and like verifying that you've actually written it properly. And so just all of these things are coming in the future. We're kind of, outside the language itself. So like you can, and it's one of those things where people who these days who want to write a language or design a language, they don't really understand that people these days, when they use a language, they want so much more than just the language. They want the package manager. They want good documentation. They want a doc generator. They want all these tools on the side that are like, not necessarily in your wheelhouse if all you care about is languages. And so it's just extremely tough to like make a language these days because you need all this stuff that people come to expect, just quality of life things. So yeah, I think there's lots to look forward to, but it's hard to say because like all the things to look forward to are all like kind of like small individual things, kind of like that you to even like, I might like say a thing where it's like, okay, like, so why would you want that? I could go on for on and on about like why it's important to have this or how having this thing fixes this small thing in the language or leads to this like, pattern, which is like a good thing for this case. And it's like, I don't know, there's all the it's kind of like it's kind of like optimizing a program where like you first you profile, you find the hot loops, you fix the hot loops, and then if you want to go further, at some point you're just like optimizing lots of little stuff. And so at this point, all the big things in Rust are implemented, I'd say. There's still some big things, but it's really at this point just getting down in the weeds and doing lots of small improvements. And that's really just what's left these days. I think, I hope someday to be able to look back and say, hey, Rust is done developing. It's kind of you look at how C has been for the past 30 or so years. Obviously, there have been new things in C, but for the most part, what people like about C is that it's done, right? There's not a lot of new idioms to learn. Old code keeps compiling by dint of things haven't really changed. And so I think maybe when Rust is 20 or 30 years old, we're just you know what? We're just done adding new features. Here's Rust. Have fun. It's done. And I don't think we're anywhere close to that being the case, but I hope someday to be able to say, hey, we don't need to perpetually add features. We want to just make the language be what it is. So, I mean, we're getting there. I think we're if you look at, the 2021 edition, the number of things in the edition are much smaller than the previous edition, the 2018 edition. So I think that's going to continue over time, where editions become less and less momentous, maybe even farther apart. Who knows? Just in terms of what is needed, what are we trying to future-proof against, what are we trying to add to the language. So yeah, I think the future of Rust is hopefully just more stability, and then working on the details like faster compilation time, better tooling, that kind of stuff.
Okay, yeah, that makes sense. Okay, that's good to hear, and I think that it definitely makes sense because there's not much. Yeah, I mean, there's a lot. Basically, everything's there, and now it's just kind of building up more crates and maybe adding in, like you said, the bigger pieces, right? So that totally makes sense. Okay, I think I use up a lot of your time. It's getting late over here.
Yeah, I gotta go at some point too. So yeah,
you gotta go home. Yeah. So, is there anything else you'd like to say before we kind of sign off?
No. So, I mean, my first time being interviewed on my own podcast. Let's do the usual pitch where it's this is, I'm not sure if you want to release this on your own, but I work on Rustacean Station, which is a community oriented kind of channel for podcasts. If you have Rust content, if you want to interview folks writing Rust or just talk about Rust, any kind of thing at all, if you want do learning materials, or if you wanted to summarize developments in the language, like John and I often do every so often with the release note podcasts, you can do that. So you can get involved. It's all open. We have a pretty streamlined thing. Give us an audio file and we'll take care of the rest generally. So yeah, get involved. Maybe when you do the release notes, put links to the how to get involved in the podcast down below there. Follow us on Twitter. Find it in Discord. Yeah, that's all.
Okay, and with that, I thank you for making time, and it's great that you can definitely join us on this, and now you can enjoy the rest of your lovely Saturday.
Yeah, thank you. Have a good day yourself.
Thanks. Bye.
Bye.